All right, let's continue. The introduction about vector in 3D to be precise. Okay, recall last time I keep repeating two important words to be exactly, scalar and vector. Okay, it is very important to tell the difference between the scalar and a vector because in order to do the math with them, okay, there are operation math. There's an allowable math and not allowable math with vector, right? Scalar, you can do anything with it. You can multiply, you can divide, you can subtract, you can do everything with scalar, aka numbers. But vectors, you are very limited with what you can do, okay? You can only multiply, you can add, you can subtract, you cannot divide, right? And within the multiplication of vector, there are different kind of vector multiplication. There are dot product, right? And there are cross product. Okay, so we're going to come to that in a little bit. Okay, so let's try this example. Okay, an application. A force with a direction and a magnitude. Okay, force is a force with a direction with magnitude. Mass m, a mass m right here is balanced. Okay, in a balanced position or stationary. It's not moving. Okay, so there's no other force acting on that. Okay, there are no other force acting on that beside the tension of the wire. Okay, beside the tension of the wire and anything else. In order to make it keep it stationary, there first of all there will be the tension. Okay, the tension is the force acting on the mast that in opposite direction with the wire. Okay, that let's call that T1 and T2. Okay, they're trying to pull it that in this direction. Okay, and in order to keep it stationary, still balanced, there's another force acting on this, which is gravitational weight. Yes, weight. Put it down. Nothing escape that. Okay, nothing escape that. Even if you're in space, you say in space you are weightless. There are still minimal small. Okay, no matter. As long as there's an object around you, even though the earth right here, you're floating over here, you are still being pulled by the earth. The moment, if you have mass, you have force. If you have mass, you try to suck whatever around you. Okay, you have mass, you always try to pull things toward you. So even the earth right here, you're floating really far away, you still being pulled toward this. But just really small. Okay, so nothing escapes this, literally. Okay, nothing escapes gravity. All right. Our job is to find this T1, T2, and also their magnitude. Okay, the magnitude. All right. So the best way to do this one is maybe I'm going to copy this diagram again. Maybe this diagram again. Just the diagram. Okay, copy that. I'm going to remove the number. Okay, so we're going to paste it here. Oops. Paste it here. I'm going to remove the number. So I just only look at the vectors only. Okay, so 60 out of window, 30 out of window, 3 meter. There you go. Okay, only focus on the vectors. Just those. Right. In order to find T1 and T2, okay, we have two. But T1 and T2 is going in an angle right now. Okay, an angle right now. How about an angle? Okay, whenever it go kind of like diagonal. Okay, whenever it go kind of diagonal. If it's not going either straight up or straight vertically or horizontally, we always need to borrow triangle. Okay, right? We need to borrow this triangle and this triangle. Okay, those two triangles. So let's zoom out. Just need one of them. Let's analyze one of them. The other one just follow. How about I bring out this one, the one on the left with the T1. Okay. Zoom it out. Enlarge that one. Okay. All right. And whenever we need a triangle, in this case, always the right triangle. Regular triangle is useless. It's always right triangle, so you can borrow the idea of trigonometry, right? Well, the goal is I'm trying to express this T1 in terms of this vector and this vector, okay? Also, I need to borrow this angle, okay? Somewhere in there, the math needs to have this angle. What do you think this one? 30, because over there, 30. So 30 here, 60 here, 60 here. Okay, so we know that 30. Okay. The goal is try to express T1, okay, a vector in term, okay, the best way to do the math with vector is rewrite the vector in terms of the basis vector, okay. Recon basis vector, this triple, J, K. Okay, we call those vector. All right, I, J, K. In here, you only need I and J technically. That is 2D problems, so I and J is enough. Okay, I is the vector that go in this direction, right? I. Okay. Is it? This is 1. The length is 1. Basis vector, the length is 1. 1 right there, that is J. Okay. I right here. J right there. Okay. So I'm putting I right there like that. Is that correct? That red I right here. Is it correct? Vector. Two things determine the vector. A direction and a magnitude. Magnitude, that is 1. Direction, positive, negative. Okay. J. Okay. All right. How do I express T1 in terms of either I or J and then that angle over there? I'm just going to write it out for you and I'm going to explain later, okay, in a little bit. So let T1, T2 be tension vectors. Okay. We have T1 is the magnitude of T1 multiplied by cosine of 30 degrees multiplied by I. Actually, let's put it here. Negative I, my bad, negative I, plus magnitude T1 sine 30 degrees J. Okay, let's put it down first. I'm going to explain why we have those two. Okay, so let's use it over here. this vector t, 1. Okay, t1, let's call this vector t1 here, let's call this vector u, v. So t1 equal u plus v, right, according to this. So t1 equal u plus v. Okay, so u and v would be these two right here. Okay. Vector u, instead of writing u, remember yesterday, on Monday, u, let's say u is 2, 2. Okay. Instead of writing like this, we can write in this basis form, a combination of basis vector, right? You can write that. Okay. So in here, this vector u is only have, okay, I'm going to write vector u, because there is no vertical component, there's only horizontal component, so there's only I, but in this case, negative I, right? Okay, negative I, because in this direction. And this number, some number multiplied by I, j, okay, right, some number. What do you think that number is? What do you think that number? If in terms of a vector, what do you think? 2 and 2. Okay, if I draw vector u, okay, 2 and 2. 1, 2, 1, 2. That is u. Correct? Right? Right? 2 technically the length. This length, right? This length, right? So in here, I need the length of this one. Right here, the length of that one, the length of u right here, multiply that. Okay. Okay, let's call it length of u multiplied by negative I. Good. Similarly, v will be length of v multiplied by j. Because j over here, I over here. Okay, good. Now let's find this length of u. Length of u, that means this length. Okay, length of that. One more time. Now u, v. T1. Okay. That is 30 degrees. This is where I need to borrow this number. Okay, 30 degrees. What is length of u in here? Okay, now let's speak in terms of their length. Length, okay, the length. Okay, what would be the length of u? That means this length, exactly this length right here. How much is that? How do we compute it? Or in other words, okay, that's 30 degrees. Can you make a connection between this number 30 to this? The ratio thing, the cosine, sine, the adjacent, the hypotenuse, the opposite. Cosine of 30 degrees, which is cosine of this equal
u over t1.
Before that, the adjacent thing. Let's speak in terms of adjacent and hypotenuse.
Adjacent over hypotenuse.
Adjacent over hypotenuse. In this case, adjacent is this over hypotenuse is this. Right? I need this, right? What is this? Multiply both sides, move this with this. So instead of that, I have the magnitude of T1 multiplied by cosine 30 degrees. That is the length of u. And then multiply by the basis vector, negative. Okay, do that again. Do that again for V. We have the second part right here. Okay. Any question? Yeah, that from physics. More or less, this got like a recon from, I believe, physics 310 or physics 180. Okay. That is where they focus on vector with a lot of vector calculation. That okay. All right. So with that being said, any question? So I just expressed T1 in terms of these two. Okay. T2 similarly. Okay. Magnitude T2 multiplied by cosine of this time is 60 degree. Okay. Plus magnitude T2 multiplied by sine 60 degree. Or this would be I, this would be J. Okay. All right. Let's clear out a few numbers in here. Anything we know? Cosine 30, sine 30. Okay. Cosine 60, sine 60. Okay, cosine 30 degree. Square root 3 over 2. Sine 30, a half. Okay, one more time. Okay. All right. Any question? So we just expressed T1 and T2 in terms of basis vector ij. Okay. And this, remember, this is a physics problems. Okay. Everything have to follow, okay, obey the physics law. It is stationary. The mass is stationary. M is stationary. Can you conclude anything about T1, T2, and W?
Net force is 0.
The net force is 0. Beautiful put. Very good put. Net force is, okay, sir, equals 0. Okay. Which is the total vector or add up on the vector T1 plus T2 plus W equal 0. Vector. Okay. In here, T1, T2. Okay. Now, you just have to add in term. Let's speak about, okay, the weight. Let's find weight first, and then we're gonna use these two. Let's find the weight. We have the mass is 10. Okay. M equal 10. Therefore, the weight is 10. Okay. What do you think about this? There's 10 in there for sure. For sure there's 10 in there, somewhere in there. Okay, 10 times G, right? Gravitational mg, right? But we have to be careful about the direction of this one, because we are now dealing with the vector W. Okay. For sure, the scalar of this one is 10 times G, 10G, without the negative, positive, anything. We don't need to worry about action. But if you want to look at the direction of this one, what do you think? Negative 10G. But that's still a scalar. Negative 10G. G is 9.8 something. Multiply both of them. It is still a scalar. We need to express that in terms of a vector. In terms of vector. Same idea with I and J. In terms of vector, you multiply by J. In other words, that is negative around, okay, let's assume this is G is 99.8, so you have 98. There. Okay. This expression right here, 3 vector add up equals 0, that means their I component and their j component add up equals 0. Okay. T1 plus T2 plus W equals 0. That means actually that is T1 plus the second vector. I'm writing in vertical direction. That's it. Okay. Okay, I'm going to zoom out and let you take some time to think about this. Okay, 3 vector add up equals 0. I'm writing them in vector by vector. The first vector is right here. That is T1, right? Remember this? Just a different way of writing vector, right? Instead of I and J, I can use this, or you can write this. Okay. Yes.
Does the length of the wires have anything to do with it?
I'm sorry?
Does the length of the wires have anything to do with it?
The length of the wire, 3 and 5, doesn't do anything in this problem. Yeah, I'm sorry. I don't know why in the text they put that 3 and 5. It doesn't do anything to this problem. Yeah. It's like a foggy to confuse you. But you don't need the length of the tension, the wire. Okay, good question. All right, back to this. So you add them up. Okay, T1, T2, okay. W, the weight. What do you think?
0.
Correct. Okay, and that equals 0. Okay, how do you write that in? Okay, how do you write that? So that now you have equation already. You literally have the equation to solve for T1 and T2. But okay, tell me, how do you rearrange this? Rearrange this so that you can solve for T1 and T2. Let's go old school. Oh no, all this smoke. Where's my marker? Okay, back to the basics. 2 vector add up equal this. How do I write that in a system? How do I write that? Okay, I give you a hint. I put this. What do you put in the middle? What do you put in the middle? In here? These 2 vector, when you add a vector, you add their component, right? X1 plus X2 equal 3. Y1 plus Y2 equal 4. This plus 0 equal 0. This plus this equal another 0. minus 98. Okay. Look messy, look complicated. But it is just a system of two equations, two variables, T1 and T2. Okay, that should be T2, my bad. This should be T2. This should be T1. There. A system of two equations with T1 and T2. You can solve for T1 and T2. Okay. By either substitution or elimination. Okay. System. Okay, there you go. How do you do this? Okay, subtract or multiply, or okay, multiply by 2, right? You can get, so this is number 2, and then you can add them up, subtract them. Okay, I let you work on this. Okay, try that at home, because this is one of the examples. You have something, one of the homework. You have something similar to this. So for this, eventually by substitution, okay, or elimination, this from pre-cal, okay, these two techniques, right? You're gonna end up with T1. The magnitude is the magnitude for T1 is 24.5, and the magnitude of T2 is 42.4. Okay, that is the first solution. Once you have this, you go back, you can find the vector T1 and T2. Okay. Plug in T1, T2, you get their vector. Okay, which is the magnitude of T1 times square root of 3 over 2 I J okay. You have these two numbers. You plug here, 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 here. You have your vector. And done. Okay. All right. Any question? The tricky part about this problem is express this vector t in terms of this vertical and horizontal vector, or express that in terms of I and j. Express that in terms of basis vector. Okay. Moving on, we go to determinant. Okay. Suddenly, when you study vector, and then why there's this determinant? Okay. Why we learn this concept? Let's say you have two vectors, u and v. Okay, so uv here. uv. I'm going to change the number to A, B, C, and D. A, B, C, and D. Then the determinant, which is this one right here, the determinant is A, B, C, D. The math is like this. Multiply A to D, okay, and subtract B to C. Okay, A times D minus B times C. That determinant turned out to be the area of the parallelogram created by U and V. More like a trapezoid. Okay, yeah, a trapezoid. Is it a trapezoid? Yeah, it's like a diamond. This is U. This is V. This area A is this quantity. Okay. So you have two vectors. The determinant gives you the area spanned by U and V. Good? Okay, so the math is this: A times D minus B times C equal the area spanned by U equal AB and V equal CD. There. Okay. If we have another vector, so in 3D, V, U, means U, V, and W. Okay, so U, V, and W. The determinant of these three vectors, what do you think? Not about not the formula, not how you compute that, the meaning of that. What do you think? If two vector, you return area spanned by that those vector. Now you have three vector, you get the volume of, maybe look like this, U, V, and W. Then you have something like this. Okay, not my good drawing. There. The volume of that thing. U, V, W. Okay. And how do we compute that? A, okay, put the plus here, put the minus here, put the plus here. Okay, it's going to be A multiplied by the determinant. So A, this number multiplied by E, I times F and H. Okay, this one, these four right here. This one in the corner multiplied by the determinant of this one. E, these four right here. A multiplied by that. E, F, H, I. Okay. Where do I put this sign? The next thing is going to be minus. Minus with the B. Okay. Minus B. But this time, you take away B, you multiply by the determinant of these four. D, G, F, I. These four. Okay, literally you drop it out. Bring this row and this column. Take it out, you have this. 1, 2, 3, 4. There. Okay, lastly, C. C, I hope you get the pattern now. With C, there is going to be the determinant of D, E, G, H. Okay, so C plus C, D, E, G, H. Okay. And each one like this is right here. Okay, each one here, these three, you just have to do this. This time this, minus this time this. Okay. How about you try that? Maybe crank it up a little bit. Try that. And tell me how much. Okay, maybe 2-3 minutes. Try that. And the answer actually surprised you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1 to 9. The determinant actually is going to surprise. I hope it surprises you. Try that. And then I will give you the solution. Okay. And then actually when you do that, you end up with the volume created by these three vectors, the parallelogram created by these three vectors, the volume of that object, that thing, that not really a cubic, okay, but that. Okay, how much? Any answer? How much? 0? 0? True. 0. Determinant from 1 to 9, actually 0. These three vectors, they actually form a volume. They cannot form, basically. When you have the determinant is 0, they don't form an object. Try to draw the vector in actual space. Try that. 1, 3, 1, 2, 3. Try to locate that vector. What does this point? This 1, 2. They point inward. They cannot create a volume. You don't see the shape from that. That's why the volume is 0. Okay. All right. Let's wrap up 10.2. Now 10.3. Continue from the vector. Now we do some operation with vector. Okay. 10.2. We add vector. We kind of subtract vector. We multiply so far. Okay. We have vector. Right. We can add vector. Vector plus vector equal vector. Okay. 10.2. We multiply by a scalar. You have vector, thank you. Okay, plus or minus, you still have vector. Okay. You don't divide vector. Okay, you don't divide vector. There's no vector division. Next thing you learn, right here, you multiply vector. This section is about multiplication of two vector. And the first thing, there are two kind of multiplication of vector, two kind of product of vector. Dot and cross. Cross is a little bit more complicated. Okay. Dot product and cross product. Dot product is much easier. Dot product, some textbook they also use another name, aka inner product. Okay. And the dot product is extremely easy to compute. Okay, dot product, you just have to multiply across their component. So x times x, y times y, z times z. Okay. X times x, y times y, z times z, and then add them up. So I have these two. Okay, the yellow with the yellow, the blue with the blue, and the purple with the purple. You just multiply them across the board. So u1 times v1, u2 times v2, u3 times v3. Okay, and then you add them up. So you put a plus. All right. After doing all of that operation, one more time, this question again. Vector or scalar? Huh? Vector, scalar. Okay. Scalar. So a dot product return, all of these are number. Imagine this is 1, 2, 3, 4, 5, 6. You add, you multiply them, you add them up, you're going to return a number. There's no vector in there, right? Clear. So first thing you're going to memorize today is the dot product always return a scalar. Okay. Later on when we learn about cross product will return a vector. We will come to that. Okay, eventually. But that is the big difference between these two operations. Okay, one return scalar, the other one return vector. Okay. All right, so these two. U here, V here. Okay, dot product them. Okay. U dot product V. This time I try to avoid saying time or multiply, okay, because we have two different multiplication. So instead of saying U times V, it could be either dot product or cross product. So I'm gonna try to specify as much as possible. So U dot product V, okay, dot product V. According to this operation, I'm gonna multiply the X component. What is the X component of the U? 0, correct. There's no I in there. There's no I component. There's no X component. 0 times 3 plus 2 times 5 plus, what do you think?
I thought the 2 would be like the last one.
Oh, the 2, the last one. My bad. Thank you. My bad. Sorry. 0 times 5, 2 times -7. Thank you for that. And that equal -14. Okay. Another example where you have a different way of writing the vector. See, one using basis vector, the other one use this vector notation. Okay, same idea, similar to that. 5 times x squared plus, oh, there should be a comma, right? Yeah, there should be a comma, my bad. 5, yes.
So for the dot product, you don't need to put like ijk or anything because it's a scalar, right?
It's scalar, yes. You need ijk, yes. You only need to multiply the component constant, okay, the component coefficient, this number, 3, 5, -7, okay. All right, 5 times x squared plus x times 1 over y plus -y times 2. Okay, you don't need to simplify that. You just know that, okay, this is how we do dot product. And all of them end up to be a scalar. Scalar here, scalar here. Okay. Some property about dot product. Okay. If you multiply a vector by itself, you return a scalar, right? But what is special about this scalar? The length of that vector, square of that. Square of the length, right? Length, not absolute value. The square of the length of this vector. Okay. Okay. Dot product, they have associated property. That means you can flip that. A times B equal B times A. No, A dot B equal B dot A. I'm sorry, not time. Okay, try that for using the word time. A dot B equal B dot A. Okay. Okay. It has also have distributive property. That means you can FOIL or distribute inside. So A dot B plus C equal A dot B plus A dot C. Okay. So this is very similar to normal product, normal multiplication between two numbers. Okay. It has very similar property. Right. Okay. D here, there's no vectors. There's no arrow, so this is scalar. Scalar multiplied to vector. Scalar multiplied to vector. You still have a vector, right? Vector times vector, you're gonna have a scalar. But this one, you can multiply A to B first, and then multiply to D after. So D multiply A, B, there. Okay. A vector dot 0 vector. For sure, it will be 0, right? What kind of 0 are we talking about? Scalar? A whole, okay, should I put an arrow in here or no? No, scalar, okay. Dot between two vector. Okay, I'm gonna give you scalar. All right. A few laws that you can apply. Okay, there are two laws. law of sine and law of cosine. Okay, to help you find the angle inside the triangle. Okay, one by one. A triangle with edge. Okay, that edge, the height. That edge. Okay, I'm gonna put the 90-degree angle here so you can see it. Okay, height of that is gonna be C times sine of A. Right. A is the angle. Sine equal. Okay, sine equal opposite divided by hypotenuse. Okay, so the height also equal, using that notation, height also equal, what do you think? The other side, look at the other side. A times sine of C. Okay. Both of these equal height. So I can let them equal each other. Okay. And that means, okay, I can do a little bit of assumption. How about the B? What do you think? What do you think? The last one. What will be the last one in here? Okay, actually, all right. Let's simplify. I hope when I write like this, I hope it makes sense to you. Sine of A divided by A equals sine of C divided by C. Okay. Just go. Okay. If I write equal, one more time. If I write equal, what would be the third thing I write? That is the law of sine. The relation, this tells you the relation between the length of a sine to its opposite angle. Okay, so A here, the ratio between sine of this angle to this one equal this to this equal this to this. Okay. Okay, next. Laws of cosine. Before we start, I already have the diagram. So vector A here, vector B here. Okay. A plus B will be vector like this. Right, a vector like this. Therefore, this one will be A minus B. Okay, A minus B. Okay. What do you think about square? Think. Okay, first draw that. Okay, if you don't have a note, I see that some of you still take a note down. Okay, take your time. Think about it. A, B. Anyone recall the cosine? Because this is law of cosine, you're gonna, okay. The right hand side gonna have something with cosine. Okay, anyone remember this property? Maybe no, but yes, no. Okay. A, B, C. Okay. C square actually equal A square plus B square minus 2AB times cosine theta. Recall that? That's from trig. That's from trig class. That's from 111. We just discussed this last time, last class. Remember this? Okay. Using this for this. So AB square is going to be that vector A, okay, the length of A plus the length of B square minus 2 times A, B, and the cosine of this angle. Okay. Instead of writing them in A, B, and OA, OB, okay, I'm going to write them in terms of their, vector A, B, and AB right there. So AB turn out to be vector A minus vector B square. OA is just A square. OB is B square. Minus 2 times A, B, and cosine of theta. Okay. That is the length of vector. Okay. Remember this? Actually, remember this one? The one in the box right here. I'm having the right hand side right now. I'm going to write in the left hand, like a left hand side. Okay, for all of them. Right. Okay. So A minus B is just A minus B times A minus B. Equal A times A plus B times B minus 2A B. But these two, you still have the length, right? Cosine of theta. All right. Just use that property for 1, 2, 3. There. Okay. Foil. AA plus BB. I'm gonna make it quick. The algebra, right? Minus 2AB equal AA plus BB minus 2 length of A, length of B, cosine theta. Okay. We are doing algebra, so let's keep going with the algebra. What can I do here? On this line, what can I do? What can we do with this? No, we swear to get this. You see this and this?
You subtract it over?
You can subtract. In other words, cancel. That is scalar, right? Dot. It is some number, right? Don't look at a vector. This is a number. This is a number. Vector, dot vector, number. Some number over here. Exactly another number over here. Okay, let's say you have 5 over here, 5 over here. What do? Right? What else?
I was asking that AA and the BB, those are still dot products.
That's the dot product, yes. That's the dot product. Where's that coming from? It comes from the dot product property, right here. The dot product of a vector by itself is that. And I'm using this, go back to this. Okay. What else can I cancel? If we do that. The -2. Okay. So you have A dot B equal length of A, length of B, cosine theta. And that is law of cosine. There you go. That is the result we're going to use. Why we do have this? This, what? Okay. In what scenario is this useful? Think. We do all of that hassle for this. For what? Okay, we have this, the result. In which scenario you need this? What do you think? Okay, imagine you don't have this. Imagine you don't have this. Your dot product between two vectors, what do you do? Traditionally, x times x plus y times y plus z times z, right? In other words, you need the coordinate x, y, and z, correct? Do you need coordinate here? No, you need the length of them. And you need the angle between them. Then you can also find the dot product between them. Right? So that is the using scenario for this. Okay? Any question? Also, let's say if you have two vectors. If say you have two vectors, A, B, okay, theta. And this happen a lot. If I ask you phi theta, find the angle formed by A and B, what do? What do you use? It's right here, right? You just need A, B divided by the length of A times the length of B, right? If I give you A and B equal maybe 1, 1 equal 2, 3, let's say like that. Can you find angle between A and B using that? Okay, that is long. This one happen a lot. Okay, see, you're gonna see this very often. Okay, so A and B depend on the angle. Clearly, that theta, the angle between them. Okay, now I want you to think of a special case. Think of a special case. Two vectors form an angle. There's, okay, what is something special can happen between two vectors? What kind of angle? You usually consider special. Unbelievable. Okay, an angle. Another angle here. Another angle here, right? Okay, a bunch of angle. Okay. Any kind of angle that you think is special. Go ahead. Go ahead. Keep going. I know you know. You, okay. A here. D. Okay, I'll be waiting. Keep going. Think. A special case. They form an angle. Which kind of angle do you think is special case? If you crank up within from 1 to 360, which one?
Like a right angle?
Okay. There. If they form a right angle, what happened? Theta is 90, cosine of 90, 0. The perpendicular. Okay. So, in other words, if dot product between two vectors equals 0, you can say something backward. You can make a conclusion backward. They are perpendicular to each other. Two vectors in perpendicular. So this property right here is used to prove perpendicular. Okay. All right. Phi 3 angles. Okay, let's do an example. Phi 3 angles of this triangle with the vertex A, B, and C. Okay. A, 2 and 1. Okay, so 2, 1. Maybe here, roughly. Okay. B, negative 2, 2. Down here. Okay, don't need to be precisely. C, negative 1 and 3. A little bit higher. Okay, C here. Connect them. There you go. Okay, our job is to find theta. So let's call that theta 1, theta 2, theta 3. Find those 3 theta. Okay. Find those 3 thetas. Okay. And this is where we apply this law of cosine over there. Okay, sorry, law of cosine is over there. Okay. From that one over there. From that formula. Okay. What do you think cosine of theta 1? Okay, maybe I'm going to change it back. Cosine of theta 1 equal a fraction. Okay, I'm going to solve using that. A fraction. Something divided by something. What do you think? Based on that. Based on that. What do you think? That formula, A here, B here, theta here. So according to that formula, cosine theta is just vector A dot vector B divided by the length of A and the length of B. There, right? That's how we got that. So in this particular problem right here, cosine B theta will be we need to vector, okay. A in here would be AC, right? Time AB divided by the length of AC and AB. There you go. Okay. Then ask yourself a question. You need 4 things in here. 1, 2, 3, 4. Can you find all of them? Based on this. Can you find them? Yes, right? What is AC? Let's write them one by one. AC equal vector, right, vector. AC equal, okay, I'm going to solve now, -1 minus 2, right? And 3 minus 1, which is -3 and 2. Remember how we develop a vector between 2 points? The later points subtract the first point, the previous point, okay? The component. AB, -2 minus 2, -2 minus 1. Okay, technically this subtract this subtract this. Right. Okay, -4, -3. Okay, so I have 2 vectors. How about the length of AC? Okay, we went over this on Monday. The length is just square root. Square each component. Okay, add them up. So -3 square plus 2 square. That would be 9 plus 4 negative. 9 plus 4, 13. Square root of 13. Okay, one more time. AB, -4 square plus -3 square. That is 16, 9, 25. Oh, that is a special combo. Fine. Okay. Before we plug in here, we need to find the numerator. The denominator is just this times this. Right? The denominator just this times this. Numerator is this vector times this vector. That means this vector times this vector. Okay, so let's do that. Numerator, AC dot AB, which is -3, 2, dot, -4, -3, and that is, okay, x times x plus y times y, right? 12 plus, minus, because that is in F 6. Okay. Any question here? On the slides? Any question? Good. Negative 3 times negative 4 is 12. 2 times negative 3 is negative 6. 12 minus 6, 6. Okay. We have everything to plug in. It's okay. So cosine of theta 1 is going to be 6 as the numerator. The denominator is negative. Not negative. Square root of 13 times 5. Okay. Very ugly number, but still number nonetheless. Right. Okay. The question asks you for theta 1. How many degree?
Inverse cosine, like 6 over square root of 13 times 5.
Wonderful. Thank you. 5 square root 13. All right. That's it. Okay. So that's theta 1. You can do that again for theta 2, again for theta 3. Okay. Let's say you're going to do theta 2. So that means you're going to have cosine theta 2 equal theta 2 equal. Okay, I'm going to write like this. Tell me if I'm wrong, right or wrong, huh? Okay. Is that right or wrong? Cosine theta 2, which is this angle. That means I need this vector multiplied by this vector divided by length of them. That's their length. Okay. Good? Right or wrong?
Right.
Wrong. It's wrong. Negative AB. In other words, BA. Remember, the vector, the direction matter. This A, okay, is not the other way around. Remember? Okay, the direction matter. BC is from B to C. That's good. That's good. But we need BA. We don't need AB. We need BA. And the length of BA equal length of AB. So not really wrong down there. But it's really big difference here. Okay. Because the starting point is B. BA and BC. The angle between them. Theta 2. Okay. BA and BC. BA, BC. Same here. If I have CA, that's wrong. Okay. AC, AB. But doing this problem, you have a really nice trick. Is BA, you just say it correctly, BA just opposites of AB, right? BA equal negative AB. Do we have AB? BA would be? What do you think? 4, 3. Right? BA would be 4, 3. You don't need to do again the math again. And also, do you have the length of BA? Somewhere in here. Where's that? Length of BA, which it is? Where is that? How much? Length, huh? Say again. 5. It's right here. Okay, you need to do so you can omit these two. Okay, and eventually you're gonna have theta 2 equal inverse cosine of some number. All right. Tell me, how do you find theta 3 in one single line? Theta 1 is the hardest one. Okay, theta 1 literally did all the legwork, right? Theta B, okay, borrow theta A, these two. Just need the math between these two. But still a lot of couple of steps in here. there's still some work you need to do here. But theta 3, okay. If you are pre-Cal student, Cal 1 student, I'm not going to ask this, but you are Cal 3, my expectation is much higher. So theta 3 in one single line. I only need this much, okay? We need this much to get theta 3. No longer than that.
180 minus theta 1 minus theta 2.
Right? Beautiful. Beautiful work. There you go. You don't do the whole thing again, right? Skip. Work. Usually people say work smart, not work hard, right? There. Okay. Just one last thing. Actually, no, it's okay. We can pick up this one next week, but before I take off, is there Abraham? Thank you. Patrick, Clara, Maricruz, Hector, Frida, Robert, Aline, Jonathan, Yaslin, Joshua, Andrew, El, Julio, Amanda, Esther, Felix, Bernardo, Daniel, Ibito, two syllable. Okay. Victor, Jonathan, Gabriel, Rocky, Adrian, okay, Josie, Aaron, Adam, Kayla, David, Angela, Krista, and Akash. All right. Have a good weekend, guys. See you next week. Start homework. Start the homework.
Professor, I just moved to this class. Is there anything I need to do for the Canvas, to join the Canvas?
Are you in the Canvas? You see Canvas already?
No, because I just moved to this class today.
Okay, you must Canvas today. Okay,
So how do I move to the Canvas today?
okay, you're gonna wait couple hours, around 24 hours. The system gonna upload Canvas for you and go there, start there, and go to the note. Make sure. Okay, now hook up with friends.
Okay.
Make sure you got a copy in the notes. Okay. All right.
I also just joined the class today. It may on your attendance sheet. I'm in the campus.
You in the Canvas though?
Yeah.
Okay. Yeah, same right here. Okay, so make sure get the notes. Okay, the format, the template is in there. But how do you fill in? Make sure get a friend or watch my video. I'm gonna post. Okay, let me pause the video. Yeah.